also contributed to organizing our conference. So I would like to thank them all. Now let us get down to the content part. So I would welcome Fedor and Alexander here. And the three of us will now present the speech of Oleg Bartunov, Fedor Sigaev, and Alexander on what we are going to expect in the Postgres 11. So Alexander and Fedor will say something while I'm running or starting the presentation. So while Ivan is starting the PowerPoint, we will tell you that together with Bruce, we arrived from FOSDEM conference, where, apart from other things, a very important event for Postgres community took place. It was developer meeting. So developer meeting that did not host that many people. That is usually on PGConf developer meeting in Canada. So I'm still learning how to hold the mic correctly. Like this, maybe? Do you hear me okay? Like this? Okay. And the noise, I believe, is average, though, pretty much. So let us start with the slides that Oleg prepared, and they're called Postgres Universal Database. And there are some informative remarks on Postgres that we have to voice. So why is Postgres a good database? Why do we need to opt for it? It turns out that the main reason is its universal nature, connected with flexibility. And using these slides, Oleg was going to show some interesting examples of using Postgres that not all might be aware of. So that your database shouldn't look like that, use Postgres. And here Oleg wanted to say that a very important feature of database management system is extensibility. So that is a chance not to use the functions that are embedded in the database from the beginning, and be limited by that, but to extend. No, didn't work. So extensibility, what does it mean? That means add your data types, functions, statements, clauses, and so on and so forth. And if you have some specific needs, for example, to implement or execute your new data type, you can do that on your own.
You can do it yourself using totally legal extensions that are attached to the product. You don't need to go to the vendor, to the developer for this. So the first example Oleg wanted to cite was the case when we started to work together with Oleg and Fedor. It was at Rambler. That was back in 1999. Rambler was turning from a search engine into a full-scale internet portal at that time. So they required a full-scale database. Oleg and I were already working Postgres, so we decided to work on Postgres. We did a lot at Rambler, owing to the flexibility of the product. Well, firstly, the first thing we saw was we required more resources. What resources did we need? The servers used by Rambler at that time was a Pentium 3, 1 gigabyte or half a gigabyte of RAM, and the disks were 17 to 33 gigabytes. So basically, it reminded of a present-day smartphone, and we need to serve a portal that would serve the entire country and was one of the world's 5, maybe top 10 portals. So what we required, we replaced join by the massive search, and to this end we wanted an extension, index extension. We need just index that's required arrays search, and that's what we did in the early 2000s. And Fyodor Sigaev was one of the authors of this functionality. We also did full text search, present-day search at Rambler. Before that, it existed, but it was used via the join between the vocabulary and the text, and it worked very slowly. But when this index appeared that Fedor did with Oleg, it became fully applicable. So Rambler uses this search until now, and they're going to present a special report about it. So what does Postgres do? Postgres is extensible. If it doesn't have something, you can easily add it. And people have been working at it, as you can see. You see there's lots of forks at Postgres, red, green, commercial. There are lots of them. They'll be appearing more and more. So Postgres has been going in with such a big crowd and progressing. Yes, and like to add here that in addition to the forks, to the fork procedure, Postgres also starts another trend, the unforking. So what was used to be fork becomes an extension of the Postgres. Cities, for instance, the distributed database Postgres-based started as a Postgres fork, and now it has already become an extension of Postgres. Here we show just the most interesting extensions. I'd like to draw your attention to Greenplum, for instance, or XSDB. VTSDB is a totally stunning thing. Use special compilation, it will appear in Postgres Pro very quickly soon. So there are various forks there. You can select any of them, you experiment with them. So a second important case that Oleg wanted to report about was the NoSQL functionality development, because many of you know too. So a very long time ago, when people just started thinking about NoSQL, this H-store appeared. Fyodor and Oleg did it together. H-store is the simple one-level hash that helps us to store weakly structured data in Postgres. So it wasn't enough, so they used JSON instead. They used JSON and JSON-B, which stores the same thing in binary form. JSON-B, just as HStore allows to work with this data, but to do it quickly. And JSON finally is one of the SQL standards. It happened 2 years ago, when the companies working with the databases such as Microsoft and Oracle understood they should support JSON too, and they standardized this support. As a result, this standard appears since 2016. So what they have with Postgres now is also being harmonized with the standard, and we hope that it's going to be one of the key features in Postgres 11. So the number of users has been growing. Lots of major Russian users have joined this community, such as Sberbank or the Federal Tax Service, but also others. Now, there's this trend. We've been showing this quite a lot. It's the transition towards open source worldwide, and this trend continues. So last year and this year, DBMs.com called Postgres the database of the year because Postgres grew the quickest worldwide in terms of references. So Postgres made a totally unique quantum leap, and it grew 56% last year. That is the quotations, the references grew 56%. You can look at the US statistics, employment statistics, and you can see how many times Postgres is mentioned. According to Oleg Bolin, I would like to thank him for this. We can see that Postgres has been doing quite well. And this is a totally new graph. We have never shown it before. We made a survey together with a well-known company for HR selection. It's about the references of vacancies, and you can see how the share of Postgres, the relation between Postgres and other well-known databases has been growing. It's almost 1 now. What is at the end is the side effect. You can ignore it easily. So, in the past 8 years, it's the effective January the 1st, because nobody looks for developers on January the 1st. But you can see that the share of Postgres has grown by order of magnitude as opposed to Oracle in the past 78 years. There was another interesting graph, Oracle to PG, it's the migration graph. And the popularity has been going down steadily because those who wanted to migrate already did in one way or another. Now, the third case that Oleg wanted to tell about is the Postgres and the Supernovae. I'm sure you all know that there are stars, and some stars explode sometimes. You call them supernovas. So Oleg Bartunov came to the database science from the supernova. They needed to store their catalog somewhere. As we all know, a short time ago, supernovae helped to learn about the universe, quite a lot of new things, because the universe has been going wider, because there are special supernova type 1 that have standard energy emission that is also based on world constants. And you can use them to understand how much matter is there, how quickly the space has been extending, and people have received the Nobel Prizes for this. The first article was published back in the 1990s. So what we know now about the extension of the universe is based on supernovas. But what does Postgres has to do with it? I'll tell you. So Oleg has been working on it for quite some time. So this is how supernova looks. So somewhere in the sky there appears a small dot, but the sky is huge. Previously, supernovas were discovered using the eyes. There was a special blink comparator. You look at two slides and you compare them, and you see something which appears. And then you think, aha, maybe this is a supernova, or maybe it's a bird. So this is how the blink comparator looks. You take two very similar looking pictures and you should find a new dot. It's very difficult to do this. So this is why this science has been progressing very slowly until IT technologies appeared and digital science. So this is the Andromeda Nebula. There's lots of stars there. Yeah, and the supernova, which are used to do so, are very far away in the very distant galaxies. So all you see around us is the stars of our galaxy. Now the question is, if we learn how to identify the coordinates of a star, how do we identify a supernova? We need to compare. What is a comparison? Comparison in database is in joint space. You need to find something which is there on one picture and which is not on the other picture. So clearly there are some errors, there are some inaccuracies, so it's unclear spatial join. So Postgres was used to do so. Astronomy condescended to databases or the other way around. Special extensions were developed for identifying spherical coordinates, like here, for instance. As a result, there's a database now, which was not there previously. It's a Postgres-based database developed by Moscow State University graduates, actually. And they use it to look for various things, not only supernova, but also other unstationary objects up in the skies. There are lots of them there. For instance, there's this big database Gaia. Why do you need to know the coordinates of bright dots in the skies? Not just because there are supernovas, because some of them can be asteroids coming to the Earth, and we need to be able to watch the skies in real-time basis and look for some moving objects. You will not be able to do this manually. So, another case from astronomy is the master, the network of telescopic robots. It is also developed in the Moscow State University, and it's clearly based on Postgres database too. Now, let us move to the future. We've told you about the past, now a few words about the future. Let me take these slides, please. And I'll give the microphone to Fyodor and Alexander. We got carried away a bit. Yes, that's right. Good morning. We'll tell you about what will there be in version 11 for sure, and what we plan to include in version 12. Just 3 days ago, we had a meeting of the developers, and Alexander attended the meeting. So did Oleg, but he was taking the picture, so that is why he's not on the picture. The meeting was in quite a closed circle, but it was quite fruitful for that matter, because we agreed on many issues on which we couldn't reach a clear consensus before that, so we'll tell you about it. Well, for instance, in that meeting we covered all the open patches, and there's this web application. People upload their experiences there. So we discussed all the open patches, and we reached a certain decision on each of them. So, I looked through, I examined, I participated in many of the developments which are now underway. I selected those that are the most interesting, but you should realize that I have not been able to include everything into that report, because some of the issues are not so obvious, others are just refactoring some change for the future. So SQLG, in my opinion, is the most important thing. So SQL JSON standard was issued early last year. So we used our best efforts and we implemented it one way or another. As a result, the community told us that you cannot write such a heavy feature in just a couple of months. So we waited for a year, and we did that for a very good reason. We were able to improve it a bit. Nikita Glukhov started working it very closely with all these standards, all these things. I listed them very briefly. It's a special means to use inside a relational database. A very simple example of SQL JSON addresses for where we describe our office, the rooms. Well, partially virtual office. So basically, this is an example of a query which you can use to export data in the table form, and then you play with the table in the usual SQL way. One thing to find out, though, we need to look not just through that JSON to reformat it, but we need to analyze all the JSONs in the apt tables. But we haven't been able to overcome this issue. We attached indexing to this thing to accelerate it. When we're working to compress the JSON because the problem is that keys are everywhere scattered, so you need to take them out and to put them aside. One more thing, a very simple exercise. People come to us quite often asking, what we need to, we don't need PLV8 just to use one field, to change one field. So this is another patch that is now coming fast, and we will also analyze it in the future. So the people who did a lot of magic around it are listed here. One of them is still on his way. Another important achievement of the future release 11 is the concurrency. It all started with a simple setting scan. Now it's an index scan. So we found David Rowley, for instance, has been able to accelerate parallel 6 command twice. So it's like, it's a spherical cow, because if you have no skills, so no concurrency will help you. So this is the most we have been able to achieve in very special conditions. Yes, we now have a parallel hash join. It was there previously too, but it was only effective when there was just one table and it was small. Now it works only for quite large tables. You simply share it. Appends. You can use them in parallel now. What is good about it? Because you can now distribute tables on table cases. and you can do everything at the same time almost. Or you can even distribute them to the various servers using Postgres per FeedEV. Another thing, the sorting, entry sorting. The main advantage of it is that who waited until the index is generated? Who was waiting for it and looking into the window? So does it happen always very quickly? Oh, I see some hands. Yes, I see some hands. So now this index takes a very short time because you can do it in parallel and you will win 3 times more. Another important thing is the partitioning. It's now the top 10, but there's a further progress with this. The improvement of the algorithm. What partitions to take out, what partitions not to take out. It's important in joining. If you take 2 partitions, the tables previously in join, but now you don't have to do one for all. You can just join the ones that you require. Clearly, it accelerates the database. You can do it many times even. There's no limitation now. You can update your entries, the partitions table entries. And if the partition key changes, then it will automatically be moved to the next partition. Well, it's still under discussion. But there's also hash partitioning there. Constraint exclusion. Do you need to use partition table at all? If you will not be able to find there anything. One more thing. When you create the partition table, you forget to create index, a local index for some field. So what can you do? Do you have to do it manually? Do you have to check all the partitions manually? Well, this has been corrected too. It is now simplified and it is now easier to administer. The updated key for partitioned is another important feature. If you want to do an update that can be moved from one partition to another, well, it would seem like all you need to do is just to move. But then as you do it, you bump into very serious problems. You move a line, for instance, and there's a commit where you need to find the updated version, and you need to another table. So it was quite a difficult patch. It is now being examined. We hope that it will be implemented one day. This is something which we're discussing for quite some time. So finally, we have procedures. Previously, we had limitations. So any function must be already in a working transaction. You couldn't make a function for non-working transactions. You could circumvent it somehow, but still it was quite difficult. We now have it. You can create a procedure that creates a transaction itself and that is implemented, and you can commit. The next thing which is now being examined, at the moment it works in SQL procedures, but we're now considering it's the first PL Python and PLP cell. Small but useful things. So the main features, the main areas of focus of the community. I discussed this. Now I will tell you about more smaller but more useful things. Well, previous, for instance, you had a choice. You either had the value totally in your table, or what it was toasted. So you were allowed to decide whether it's toasted or not by the values that had to be stored in table up to 4 kilobytes. So you couldn't say anything. And now you can tell the program that if it's longer than 256, let it lie in the table, and if it's shorter, then I don't need it. And you can set it for each column. because one column maybe is more important and the other is less important, so you can set it. Another simplification of the administration. Quite often when you experiment, you need to do vacuum for one table. We all know it, we'll know how to do it. You can want it to do for the entire database too. We all can do it, but the database can be big. What can you do if you have a number of tables? And a number is not just two. If you have several thousand tables, I need to work on hundreds. You create a script and you do the circumvention, and you can set the analyze for vacuum.
And what is practically not visible to users, that is improvement in atom transactions, and they will see that just the database will be faster under certain loads, and instead of 2, it will be most likely 1 in certain cases. And those who used to jump around SPGs, that has pretty narrow application, but where it helps pretty well. And now there is a compress method. So in SPGs you can insert not the exact values that are likely to be there or that might seem to need to be there. And now, well, the good example will be polygons here that are hard to index. So it is possible now and pretty easy to do and fast to do in SPGs. So application of SPGs, like further correctly said, used to be pretty narrow, and it is going to expand, and SPGist community welcomed this very well. So Postgres community welcomed this very much, and SPGist can be applied now much wider. From time to time I encountered a question why while segment is so small, 16 gigabytes, and now we can try and test, and you can set the size of while segment. It can have certain drawbacks as well, so first experiment. As for improvement in terms of XPath processing, working with XML, if you use it, you know that you cannot use a short query in XPath, and this default namespace allows to shorten that when you manually type it in. If you migrated from MySQL and Microsoft SQL, you know that by default comparison of strings in Postgres is pretty sensitive with consideration to case, and there were certain drawbacks because index could not speed up the processing. Just you needed to have a database in local C, and now you can build your index with ctext pattern ops clause, and therefore you can speed up the processing. Those who used to work in large installations of Postgres or any other relational database know that cold start over of database can lead to large temporal costs until cache warms up. And what could save in restart can now be as a module that goes by default with Postgres. Different customers regularly ask us whether you can hang something on the event of user login, logout, and there is a hook now 4 sessions, but that is not at SQL level, that is on C. So you have to wait or write yourself an extension that would be used here. As for optimizer improvement, the limit used to be on the very top or the very last. Now the limit under certain conditions can be pushed down to the table itself, and that speeds up Postgres thanks to query optimization. Another thing is bitmap index can only count, so just words collection. So everybody knows index only, and everybody loves it. I don't know people who don't like it, and index only count turned up a very long time ago, and if index can only count is impossible through bitmap, you can count under certain conditions. And now, if Postgres senses these conditions, it does not go down into the table, but it will give out the result from the index itself. And I will tell you a little bit about where it came from. First of all, it is topical for full text search, where there is a gem index, reverse index. And the first problem that we faced, if there is a query with bad selection, it means that we select a lot of links from index to heap, then we sort everything out, and it is very slow. And first we did index method room that allows us to select from index on relevance without going to heap, but then the problem stayed with count, and that is a patch from Alexander Kuzmenkov who managed to eliminate that problem. So we take bitmap from index and then count the returns, the results fast. Another point, now Postgres can distinguish selectivity of transactions lower than, equal, or more than. So now Postgres can distinguish this selectivity, and it allows us to build more correct and clear plans. And another thing is page-by-page optimization of hash index. It can now be restored from backup, and we used to read from index page, close it, then open heap page, and so on and so forth, close it, and so on and so forth. Now we open the index page, read everything in it, store it in memory, and go to the table page. So it just shortens input output, working with this. And aggregates improvement, aggregates performance has been improved. So for end user, nothing changes. You use aggregates the way you did it before, but now they are much faster. Next thing, wait for LSN. There is no emulation. You have asynchronous replica, and you would like to make sure that the data that you write on master are present in replica. So you remember the position in val where you were when you committed it, and now you then wait for it to run on replica. And another application is that is one of the ways of learning whether replica has been loaded in the app after a long pause. So in replication mode you can use remote apply, and this way is to have application just to wait to be rolled out for replica for some transactions, and you can also set some individual timeout and so on and so forth, so it is more flexible. Another thing that again is not practically visible at the user level, but the side effect of this improvement is that tables that have a lot of updates will have the space used more effectively. And the page is less fragmented and vacuum works better. And, for example, in architecture there are some problems that processes do not communicate with each other effectively at different sockets, and there are problems with memory access, limit sockets, and in some cases I saw it when it is cheaper to go to the disk. And certain improvements of low-level blockings improves this situation. And samely, you can use status of transactions while you get snapshots. Even it will take us just another 5 minutes. Improvements in PGBench and PSQL clients. Now in PGBench there is normal scripting, and in PGBench now you can execute more complicated job scenarios, and now there are new random numbers generators that enable to have so the ordinary evenly distributed random numbers generator does not enable you to distribute the load correctly. And now in PGBench you can use it better. And one of the most important patches in PSQL is that now you can exit it with quit or exit commands. And what is in discussion is Vim style exit of PSQL, but that will be in Postgres 12 already. And we hope that we will receive less questions in terms of how to exit PSQL. There are also a number of patches and improvements both in PGBench and PSQL of different nature, and we'll not focus on them now. So work mem over 1 gigabyte is not used effectively, and that is being improved. Memory is getting cheaper and cheaper, machines are more and more in number. And Tom Lane suggested that, well, any database does not like OR clauses, and he suggested that we can convert OR into union, and it must work. So that is under consideration. So incremental sort, the author will tell us about it. So in terms of incremental sort, if you have an index on one column and you want to sort on two, because in prefix you have this index, and incremental sorting reads the data in groups where the values of the first column coincide, and carries out small sorting, and it is really cheaper than sorting all at once. And I wrote this patch in late 2013, and still there has been this fight if this type of sorting will get to some issue in overhead, but now it looks like it is more or less okay, and I hope that it will be present in Postgres 11. Another thing, recheck on update. If you have encountered functional indexes and complicated ones under heavy load, you know that very often update starts running slowly, because Postgres cannot determine whether it is possible to use the write without touching upon the index on the same page. And now I hope this feature would turn up, but it will be switched off by default. So if you depend on that, don't forget to have a look at it. Next point, partition-wise aggregation. So now you can have aggregation at partitioned table, but the improvement here is that certain sub-results of the aggregates can be pushed to the level of partitions, and if your partitions are distributed in table space, it gives you a benefit in terms of performance again. Those who use the Room or Bloom index, you know that it generates a large while traffic, and now Oleg Ivanov decreased it, and under certain conditions. So the benefit will be 10 times in terms of write on disk, but the disadvantage on the CPU is present. So now there is this generic while compression. Merge join, now you can have join on ranges. And in Postgres, there is insert on complete certain action, insert on conflict update, for example, that allows you to do upsert transaction. And the main task was to solve all concurrency issues. So that is a transaction that would not return you unique violation, because you use the command on purpose not to process unique violation, and it returns to you. And it is not possible to avoid all concurrency issues. Therefore, the initial version will be more like syntactic sugar that can have unique violation and so on and so forth. But when we satisfy the standard and do it all, we will think how in certain particular cases we can get a merge behavior closer to conflict. Another, stable functions by default should not change their values in progress of processing the query. Otherwise, they could have been computed. Now, there is this patch, and it is under close study, and most likely it will be in place, and that will also have performance effect. Now, JSON-B, PL Python, and PL Perl have a string and parse these languages, and transform allows to understand the languages in the direct view in Postgres. 64-bit transaction in Postgres. So at developer meeting there was the following Postgres. It was decided that the large patch should be broken down into two at least. One will be done in memory view of seeds of 64-bit, and that is a patch that has to be committed. And what is more complicated is disk view of seeds that will stay as it was so far, and then there will be separate discussions on that, and at 5 today I will have a presentation on that, and there will be possible to have a separate type of storage. One of the main values of a 64-bit transaction, I hope that wraparound will go away. Not while we are alive, I believe. I think while we are alive. Next thing, logical decoding of two-phase transactions. I will be really very fast. So now they behave as ordinary transactions only after commit, and under certain conditions that is not convenient. So that is an improvement. Now gist, gene, and hash indexes would be able to be used at the level of serializing, and then we have compression methods, JSON BC. For this application it is done plus TS vector. For example, compression method, it is specific for specific data types, and there is an example for JSON-B where we can understanding that it is JSON-B, and very often keys are repeated. There can be a separate glossary for keys, but for for example, a text space is written in natural language, for example, Russian, but it is pretty short, not large enough to have enough time to train the glossary. But you can have a pre-installed glossary dictionary for Russian language. And now I will just voice it all really very fast because we have very little time left. Covering B3 indexes, index vacuum has become much faster, and there are new methods of work with task area and merge join on non-equal operators, global indexes on a partitioned table, generated columns like in other databases, parameters of op classes to improve the performance. And Oleg Bartunov and Nikita Glukhov will make a presentation on it.
The future, but already here. Harry Bubblecom is also one of the co-authors. We'll have a special report about it today. All right. Just-in-time compilation. Improvements in merge by Simon Riggs. Constant Konizhnik has been working, is testing, experimenting what you can do if you do threading. Or you can try and attach pulling, because as you know, Postgres does not like too many connects. But we're now experimenting it, and pulling allows increasing connected connections up to several thousand. Konstantin Knizhnik starts Karlovich TM API to Postgres, so that you can work with multi-master, sharding, etc. They developed it a long time ago, only it's another attempt on the part of the community. Auto-prepare for any SQL queries. Okay, I'm on time. Thank you for your attention. Thank you. Now we'll make a short break, just 5 minutes, and then this next speaker will be Mark Lockshin from Mail.ru. He'll tell us about migration from MySQL.